dimensions. Okay, so today we're looking at analytical geometry. The first part of our lesson, we wrapped up our heights and distances in trigonometry. So tomorrow we will sort the balance of those sums out, and we'll carry on with our analytical geometry. Okay, graph is on, 3 graphs on Monday. No? We'll have 1 or 2 lessons on 3 graphs. Okay, 3 graphs. Please do the exercise. So when you come on Monday, you have enough questions pertaining that. Okay, because last year it was 3 graphs was the worst answered question for our school. Okay, the worst answered question. So we're going to try and spend a little more time on it, because we would like you guys to do well. No? Although you guys don't feel like you want to do well, but I would like you guys to do well. No? Right, so analytical geometry. So we are told in analytical geometry on page 239, we are told that analytical geometry is a method of representing and working with geometric objects algebraically using coordinate systems. Okay, where did you use your coordinates before? Geography, yes. Using in geography, mathematics is, helping geography out. So, coordinates, yes, that is coordinate geometry. Alright, you've got the longitudinal lines and latitude lines. No? And those two meet, that is a coordinate. Not so? Alright, so same here. Many properties that has been studied in Euclidean geometry can be translated into algebraic definition. Okay, now Euclidean geometry, when we spoke about parallelograms, rhombus, kites, and all of those things, also filters into this part of the world. Okay? I'm giving other methods of proving geometric properties of plane diagrams. In this chapter, you will study the algebraic properties of diagrams such as straight lines, triangles, quadrilaterals in 2 dimensions in the Cartesian group. Okay, exactly what you said there. And here's a lovely painting, right? These are our art students. There's something for you guys too. That Rudolph, this guy, he was he lived from 1889 to 1953. Okay, that's many years ago. He was analytical geometry in this painting. So you can ask your art teacher, who does art? Only one person. The one person thinks so. You don't do art? No, nobody knows. Okay. So then they ask your art teacher who this guy is. Then she say, I don't know. And then you say, no, he was, a painter, and he used geometry, analytical geometry to do this painting. Okay, beautiful painting. I think I should get me one like this. But on my paycheck, I don't think I can get this. No? Maybe when the day you guys are millionaires, no? Don't forget me. Alright, I'll probably still be here. Or dead, no? Right. We'd rather go with the former than the latter. Okay. People, this is between 2 points. Here we go. This is the example on page. Give me the reference there. 240. 240. Example on page 240. Morning. Right, so in the example on page 240, we said if S, which is negative 5 and 0, T, which is negative 3 and 0, P, which is 1 and 0, and Q, which is 3 and 0, are 4 points on the x-axis. Okay, my idea was not to have the solution here. Okay, but there we go, solution is not there anymore. So the question says, determine the length of PQ. So if we look at PQ, this length here, from there to there. What is the length of PQ? So it's going to be the length of PQ. It's going to be from 1 to 3. How can it be 4? 2. Not so. How do you get that? 3 minus 1, which is 2. Nice. Let's look at B. B says determine the length of TP. TP. What is that length? Sorry? The length, how can, if you ask somebody, if you measure somebody, can somebody be minus 3 meters? Okay, 3 meters is really tall. But can somebody be minus 1,5 meters? No! What's wrong with you? Can length be negative? No. So what is the length between TP? It's 4 years. From negative 3 to 0 is how much units? From negative 3 to 0? 3. From 0 to 1? 1. Together it makes 4. Malu, what's wrong?
No, that's what you said, from negative 3 to 1.
Negative 3 to 1 is 4 years. But my question was from negative 3 to 0. So you said 4,
No.
which is 3. Then I said from 0 to 1, 4, which is 1.
No, because the answer is wrong.
You thought I'm wrong. How much I know of you? But how did we get that? We said 1 minus negative 3, which is 1 plus 3, which is? Let's look at C. What's the distance? Or what's the length of ST? 2 units. It's easy to see here it's 2, no? But how do we get it? You say for ST, it's going to be negative 3 minus 5, which is negative 3 plus 5, which is? Not an ohm, and it's an origin, 0 there, no? Not an ohm. Right, any confusion there? Right, let's see what Mickey Mouse says here. Exactly what we did. Okay. Normally we say the bigger number minus the smaller number. So between negative 3 and negative 5, negative 3 is larger, not so? You must closer to the 0 now. The 0 marks. Nam, you with us, my girl? Huh? Why is it so loud in that room? Huh? Are you okay then? Why don't you guys play with her? Huh? You guys don't play anymore. You don't play too much. Nice. Right. So we carry on page 240. Example 1. I've named this example 1. That's example 2 then. See, that is why I copied the answer with that. I didn't know it was an example. Okay. Example 2. In example 2 on page 240, we said if A is equal to, if A is 2 and 2. So let's get the Cartesian plane up here quickly. Let's borrow this from the grade 9s. You know, the hot days. The warm days. Not the hot days, the warm days. You were still doing graphs, you remember? You don't want to go back. Alright, so we are told, let's just make this a bit smaller. So we are told that A, which is 2 and 2. So let's do the markings here. 1, 2, 3, 4. No? 1, 2, 3, 4. 1, 2, 3. Minus 1. Okay. A, which is 2 and 2. So x is 2, y is 2. Or by approximation. So A, which is 2 and 2. B, which is 2 and negative 1. This is 2 and minus 1. C, which is 2 and minus 3. And D, no. Those three are 3 points of the Cartesian plane. Question says find the length of AB. So what is the length from there to there? How do you get 3? 3 is correct? It's going to be AB, the bigger one, minus the smaller one, not so. So it's going to be x of A minus x of B. So it's going to be, sorry, not x but, it's a y. Y of A minus y of B. So it's going to be 2 minus minus 1, which is 3. 2 plus 1 is 3. You all agree with that? Let's look at B. Find the length of AC. Yes? You can. But you see, what we're going to do now, we're generating a formula. You'll see it comes out to a formula. Okay, I know you can see it's 3. Okay? But like I said, we're going to now generate the formula that's coming. Okay? Let's look at B, find the length of CA. So I'm going to find the length of CA or AC. It's going to be the top one minus the bottom, the big greater minus the smaller. Not so. So it's going to be y of A minus y of B. Not so. So this will simply be. Sorry? C. Yes. So this would be 2 minus negative 3. So it's going to be 2 plus 3. And 2 plus 3 is? You see that length is 5. And we know it's 5. Not so? Now you do for me C quickly. Okay, so what would that be? For BC, BC. So that would be the length would be YB minus YC, which is negative 1 minus negative 3, which is. Do you guys understand? Any confusion? Homework exercise 11.1. The whole exercise. Some people, we are in the FAT band now, no? So must do a little more than what we did before. Sorry? Right, you guys can start with it now. $241. People, don't waste your time. Okay, let's start here. Alright. Bell's in a ring soon. I'll stop the video at this point. But I will check your books now. Okay. So get started with 11.1. Okay.